Okay, today, super intense day of factoring. We even learn a new technique that is something you're going to use, in fact, two techniques that you are going to use for the rest of your mathematical life. They're like big deals, and you don't know how to do them at all today, and you'll know them and you'll use them a lot. In fact, this is on the list of ACT skills. It's on the highest level. You know, like some of them are in the easy level, like, you know, you could get a 16 on the ACT, which is really low, and, you know, like, and not know this. But to get a high level score, you'd have to be able to know this thing for today. All right, without further ado, it's based on long division. And if you don't know how to do long division, I will teach you. Here's the thing. Some of you, when you learned this the first time, you were seriously like 8 or 9 or 10. And you're a lot smarter than a 10-year-old now. Okay, most of you. I do want to know, if you can do it, do it. And I want to know how many of you can, because usually it comes down to, there's like 8 people or so in a class like this that can already do it, and they're fine. And it seems kind of silly to me because we're in an honors high-level math class, and I'm talking about plain old-fashioned long division. I'm not shaming you. I'm not, because I think it's amazing that you really don't actually have to know this to do high-level math. But we do need to know it right now to do this high-level math, because it's all about polynomial long division. So we're not just going to be dividing numbers. We're going to be dividing big old equations by each other. It's called polynomial long division. All right. How many of you have got an answer already? Raise your hand if you have it. I was predicting 8. Keep your hands up. I really want to know. 1, 2, 3, 4, 5, 6, 7, 8. Boom. Maybe 9. Okay. So everybody put a 2 right there if you haven't already. Because 7 goes into 20 2 times would be a 14. If I went in 3 times, that'd be 21. It doesn't go in that many times, so I'd have to say it goes in twice. That's what that means. And now I go 7 times the 2 is 14. Please don't talk during this most intense day of factoring of your life. All right. So now I'm going to make this the opposite sign. I know some people would just say, oh, it's subtract. You just always subtract. But in polynomial long division, you don't always subtract. You always make it the opposite. You know what I mean? Like negative b. B isn't always negative. It's the opposite of whatever it was. That's what this is. You make this the opposite of whatever sign it was. Sometimes they'll be negative to start with, and you'll have to make them positive. All right, so anyway, we're going to put a minus there. And then what is 20 minus 14? 6. And then you ask yourself, does 7 go into 6? No. And you can't just, like, well, you actually can just stop right there. If you were in elementary school, you'd be able to say, okay, so I've got a remainder of 6. It went into 2. And then 2r6. How many of you guys remember actually writing it that way back in the day? Okay. Now, if you never learned that, you just did. It's not like you have to say, well, I can't do this because I never learned that. I just showed you. It's not that hard. Okay. Now, one thing they may or may not have gone to is that this 6 could be put here, and you could say the answer is 2 6/7. Do you know what I'm talking about? Because do you get 2 6/7 is like almost 3? See, it goes in there almost 3 times. Another way to say it, this times this gives you 20. Okay. Now, just one more of those for good measure to make sure you really got that. Put 8 into 430. Pay attention. Try the one that's on the board. I understand there's a way to make it a decimal, but for what we are doing, we don't need to make it a decimal. I got to focus on just what we need for right now. Long division of polynomials never involves a decimal. If you wanted to know what the decimal was, it was 6 divided by 7, which would give you a decimal. And there's a way to do it with decimals. I just don't want to take the time right now. All right. So, Mr. F, would you tell me how many times 8 goes into 43? You could say 8 goes into 4 0 times. If you want to put a 0 placeholder, you can. Does 8 go into 43? 6 times 8 is 48. Too big. 5 times. 5 times 8, 40. Draw the line. Make this opposite. 43 minus 40, 3. Now what do you do? Bring down the 0. Does 8 go into 30? Yeah, how many times? 8 times 3 is 24. Subtract, got a 6 left. Does 8 go into 6? Is there anything else to bring down? No. Then I'm done. And I would say, just listen to this question now, because this is how it's going to be on the polynomial thing. Is 8 a factor of 430? No, because it didn't come out with a 0 remainder. 8 goes into 430 some decimal number of times. Not exactly. Do you get if this would have come out to be a 0? Then I'd say, yeah, 8 does go into 430. But I have to say, no, 8 doesn't go into 430 as a factor. What if I wanted it to work? I'd have to say this over that. 53 and 6/8 times. Okay, so unless that works out to a perfect, nice whole number, then I'd say, no, it's not a factor. How about 2 going into 226? Do you think it'll go in? Well, you know it's going to go in. Okay, so we know that means the remainder will be 0. Get what I'm saying? Just do that one last one because I want one of these to work out with a remainder of 0. So put 2 into 226 the right way. Do it one step at a time. We're practicing for when these are polynomials in a second. Yep, 2 goes into 2 one time. Bring down the 2. Yes? Yes, you can absolutely simplify that. That'd be good. I just wanted to use the same numbers that were there originally so people knew that it came from here and here. But you're right. 3/4 would have been better. All right. I heard the question, why would you bring down the 2? If you only have a 0 here, you stuck with, can 2 go into 0? No. And that's why you have to bring down the 2. All right, it goes into 2 once again. 2 times 1 is 2. Draw the line, make it opposite. 0, bring down a 6. Does 2 go into 6? Yeah, how many times? 3. 3 times 2 is 6. And this time, 0 remainder, which means when you're asked the question, is 2 a factor of 226? You would say, yes. All right, good. So now, here's the more complicated kind, and here's why you need it. Don't write this down. Don't write this down. It'll just waste your time. I'm not going to actually do this one. I'm showing you the future. That is a typical question on your next test. And they'll say, is x plus 4 a factor? And you have to do long division and figure out if it is. Yeah, you'll do it and you'll like it. All right. All right, so here's how it works. I'm going to give you a nice simple one. Actually, wait a second. I'm going to give you a nice simple one. X squared plus 4x minus 5. Put it underneath the house. I like to think of that as a den. You know why? Because the thing underneath it is called the dividend. And the dividend is in the den. Besides, I like black bears. And beets. Boom! There it is. All right, so over here, x, and then minus 5. This, boys and girls, is long division of polynomials. And now some of you are like, I don't like it already. It's not that bad. It really isn't. When we put our answer, it's up here, right? I mean, that's what we just did a second ago. All right. So I'm going to make super fast over here. I'm going to just put an example for you of another long division that we just did a second ago. Okay, that's what we did before. Let's see how this is just like that. The first thing we had to do is figure out what to put up there, right? And I've got a tip for you. When you're doing polynomial long division, you pretty much always start with an x. Put an x up there. Now I'm going to go x times the x, just like I did this, right? 2 times 7, and I put the answer here, right? X times the x makes x squared. Do you think I should just like leave out the 5? Of course not. X times the negative 5 makes negative 5x. Draw a line. Now wait for a second, because a lot of people want to, like, right there just subtract them both, and that's not right. Do you remember me saying that here we always subtract, but here we have to do the opposite sign? So we go through and make this the opposite and this the opposite. You make them both the opposite of each other. Now I'm going to add them straight down, and what happens when x squared runs into negative x squared? You get nothing. They're gone. And what's 4x plus 5x? 9x. And then I bring down this 5. And I forgot the minus, sorry. Okay, you with me so far? Now I got to put another number up here, just like we would do here. If we wanted to keep going, we'd put another number up here. What's a number that should go there? You start with x, but then you have to, like, the next number you have to put is probably a number. What do you think I put up there? 9, very good, because 9 times the x makes 9x. I know, just hold on. 9 times the negative 5 makes negative 45. And some of you are noticing this is going to have a problem. I make this the opposite. I make this the opposite. And final answer is positive 40. Was it a factor? No. Bottom line is you've proved it was not a factor because it had a remainder. And so that is a typical test question. And you don't even have to, like, get an answer sometimes. Sometimes the answer is, it doesn't work. And here's my proof. I had a remainder of 40, so it didn't work. All right, now I want you to do the same exact problem, except with an x plus 5. And this time it's going to work. Try it. This is the easiest way I can show you. I just did that problem with one different sign. Okay, give it a shot. Don't just sit there. This math's not going to learn itself. Someday you'll be able to just plug it into your little SIM socket on the side of your head. I know judo. I know kung fu. Yes, it's from the Matrix. But for now, you have to learn it the old-fashioned way. I love that. I'm just going to wait. Someday they'll be able to give me all knowledge on my brain implant. Yes. I'm going to pause for just a second. Okay. Hopefully you're smart enough to put an x up here. X squared. 5x, draw the line. This is where, you remember me saying before, this is a really important part where you make it the opposite? Opposite, opposite. Now I get negative x minus 5. And I bet you somebody in here got this one right away with a negative 1. Raise your hand if you knew it was a negative 1. You are right. Okay, so I multiply that out, negative x, and multiply that out, negative 5. Draw the line opposite, opposite, so that when they add, you get 0 remainder. That means it worked. Raise your hand if you did right. Okay. Didn't do it right? Okay. All right. Got to get this. We're not done yet. All right. The question would be, was this a factor? And the fact we got a zero remainder says yes, was a factor. Yes? Does the x on the top have to go there? Yes, you have to put the x on the top. Just like the 2 here, I had to put the 2 there. 7 times 2 is 14. You know that this gets multiplied and goes there. I need that number on top, yeah. I suggested that you start with x, and if it doesn't work, you tweak it a little bit until it does work. How do you know if it works? Because this times this has to equal that, and this has to be the same so that they'll cancel. All right, I'm going to do another one. It's just a little step up first. Question? I'm sorry, I got to keep moving here for right now. I do, but let me get people started on a problem first. All right, everybody try this one. X plus 3 into x squared plus 0x, I know that feels weird, minus 9. Don't let it bother you. I just put in a placeholder 0x. It's okay. Everything is still going to work like normal. All right. Get to work on long dividing that puppy. I'm going to pause for a second. Let me give it a try. All right. I think most of you knew we should start with an x up here. X times x, x squared. How would you have known if it hadn't worked? If these weren't the same as each other. Those need to be exactly the same. Okay, so it worked. Yay. And then 3 times the x, 3x. Draw a line, opposite, opposite. Negative 3x. You got that? Bring this down, minus 9. Then minus 3. Why'd I pick that? So that this times this would be the same as that. Okay. And then that times that makes positive 9. Ruh-roh. I screwed up. I shouldn't have used negative 3, should I? What'd I do wrong? Okay, hold on. I got to try that again. Negative 3 times x is negative 3x. Negative, I will after I'm done. Negative 3 times positive 3 is, there we go. I changed one of them, but I didn't change the other. Now I get it. Opposite, opposite. Everything cancels. 0 remainder. It worked. Raise your hand if you did that one right. Okay. Now let me show you that you can even handle really big, scary ones. That one's called the dividend because it's in the den, like a big bear. And then out here, we're going to say x plus 4. So the question would be, is x plus 4 a factor of this polynomial? Whether you're learning this or not really will depend on your willingness to try and even your willingness to fail, because if you are willing to try and do it wrong and then ask somebody like, what am I doing wrong? And then they show you, then you can fix it and learn it. The worst thing you can do is just sit there and go, oh, this is confusing. Gotta try. Gotta do. And if you're Yoda, you'd say, do or do not. There is no try. So, today I've quoted Yoda, and I will be quoting Snoop Dogg later this hour. Stay tuned. Do you remember me saying to just start with x? Did that work this time? No. So then if it's not x, x squared, because that way, when it multiplies by this x, it makes x to the third. Very nice. I think most of you caught that. Guys, are you doing math? Okay, good. All right. And we're good. You were laughing so much that I was afraid it was watching a Snoop Dogg video or whatever. Okay, that times that is 4x squared. Draw the line. Opposite, opposite. This is complicated, detailed stuff, but hey, it's kind of cool. Most kids hit the ACT test, and this question can be on it. And I would honestly say that only 1 in 10 kids can do long division. You will be one of the 1 in 10. It's not that scary. Sounds scary, looks scary, but it's not that bad. Everything canceled. Now, since everything canceled, I can, but don't have to, put a plus 0x here to hold that place. I do not have to. I've tried it. I've checked. You don't have to have that there. But if it makes sense to you, go ahead and put it in. It's optional. Okay, then. This has to come down for sure, and I won't have enough to do it because this has 2 terms. So I bring down both of them. That's why I have this 0 here, is because bringing down the -2 wasn't enough. Don't have to have that there, though, because it's just going to disappear in the final answer. All right, and then I betcha you figured out it's -2. -2 times the x, -2x, -2 times the 4, -8. Draw a line, opposite, opposite, or 0 remainder. It worked. All right, now if you say the answer is yes, then there will be another blank on the test that will say, what is the final factored form? Just to clarify, do you get that that times that equals that? So it's x plus 4 times x squared minus 2. There, that's factored form. You just take 2 numbers, 2 answers, the one that's on top of the den and the one that's outside the den, and they're there. You have to factor it all the way, but this one is factored all the way. Now you might say, but Mr. Server, you taught us how you could do this. You're right, I could do that, and it would be okay if you want to be the extra smart kid who knows that it's this. You do not have to. But I will say the kids that can do this have an advantage, because the next blank on the test is, and what are the zeros? And if you factored it this way, you can just go, okay, -4 is a 0, positive square root of 2 is 0, and negative square root of 2 is a 0, and I got all my answers. So I think it's an advantage if you can do this factoring, but you don't have to. This would have gotten credit. All right. Now, one last kind I have to teach you. And actually, honestly, a lot of you are going to like this better. It's a different way to do that problem. And I know some of you are like, I've already got a way. I barely can handle it that way. Don't give me any more ways. But this way, I'd say in a couple days when you are given a choice, 80% of you are going to pick this way because it's faster. Okay, so let me show you the faster way. Okay, say the problem was this one. And I'm glad you know about grouping, and we'll come back to that again tomorrow. But for right now, focus on the long division aspect of this. Let me think. Okay, write this one down. And then I'm going to show you a way faster way to do it. I think most people would agree that if you can do something 3 times as fast, that's better. Okay, so here's the 3 times faster way. Remember, the question is this a root? Or is it a 0? Is it a factor? Do you get what I'm talking about there? I should say it this way, just because the way I said it before is this a factor of that? Is the question, okay? And you can do long division, and if you get a 0 remainder, that means it's a factor, okay? But what's the faster way? Watch. Why did it pick -2? Because it's the root and it doesn't have an x, so it'll be faster. Next, I'm going to choose 2, 4, -6, and -12. Draw a line like this. Set that all up. I'm going to pause for a second. Mic was off. There we go. I dropped that first 2. Drop it like it's hot. And then I multiply here, and you're probably thinking, why on earth would I do that? I can tell you that what we're doing is actually replicating the long division we would have done, which involves multiplying things and then adding things up, right? This just pulls out all the variables, and I just take numbers, and I add them and multiply, and add them and multiply. So watch this. Drop it, multiply it, add it, multiply it. Okay, I'm going too fast apparently. I'm going to back up a notch. All right. This goes 2 times -2, and it made -4. And now I'm going to add them. Oh, come on, you can handle that. And now I'm going to multiply them. What's 0 times -2? 0. Now I'm going to add them, -6. Now I'm going to multiply them, +12. And look at that. 0 at the end. It's got a 0 remainder. Therefore, it's a factor. It is fast. It had a 0 remainder. All right. I didn't make it up. All right. Now, even better, you might say, well, on the other one, I could see what the factors were. But you still can hear, gentlemen. Now, okay, I'm going to be moving you up to the front row if you can't, like, control. Keep it under. Okay, thank you. All right. So this also tells me the factors. Watch. See if you can handle this. That is an x plus 2. It's because it came from there in the first place. And this, 0x's, 2x squared's, final answer, 2x squared plus 0x, which I don't really need, but I'm going to put, just to keep it clean, -6. That times that are my factors. Yes. How did I get the squared? All right. When I have numbers in a row right here, too much talking. Settle. All right. So when I have these numbers along the bottom like this, that one's the remainder. You never use the remainder if it's a 0. You just know it worked. And then this is always the constant, no x. This one will always be the one that has x's. This will be x squareds. And if it keeps going, it'll be x to the thirds, x to the fourths, x to the fifths. All right, so let me just show you a pure problem. That is synthetic. And I want you to tell me if 2 was a root. Write that down. Drop it like it's hot. The what thing?
There's signs, like they come and talk about like science.
Oh, NASA, yeah, go for it, have fun. All right, I'm multiplying. And I have -1 times 2 is -2. Add them, 0. Multiply them, 0. Add them, 0. Multiply them, 0. Add them, 4. Ew. Did it have a 0 remainder and therefore work? No, didn't work. So what's the answer? The answer is this was not a root. It was not a solution. All right. Last one, and this one, I want you to try it. I understand. in both long division. It's going to be a nice, easy one. Long division, and then do with synthetic. And I think you'll see it all come together. Try it with long, then try it with synthetic, and I bet you'll see it work both ways. Gentlemen, this is your last chance. If it was him talking again, he would have already burned his last chance. You guys, you're talking too much. Just stop it. Stop it. All hour? You've been explaining to him all hour? That doesn't seem possible. I know, it's a hard day, but that doesn't mean I want kids talking all hour. So there's long and there's synthetic. If you had to, you could get by with just long. Long division would work on every single problem. If you don't even want to deal with the synthetic thing, you don't have to. But honestly, it's so much faster that 80% of kids will choose that option on the tests. All right. I want you two to compare. I want you three, because you don't have somebody right next to you, to compare. You two compare with each other, forward and backwards. You two compare. You ready? Let's see. You get with the person behind you, AE. You two compare right across from each other. These two rows, person right across from you, pretty obviously. Compare with them. See if you get the same exact thing. If they have trouble with synthetic, help them. Yes, you're supposed to do synthetic too. Now, I'm sorry to be pushing you this hard. I feel a little bit like a elephant trainer who has to smack the elephant with a stick a whole bunch of times to get him to do this really difficult trick. But you know what we just got through today? That was 3 days worth of material. Normally, you just teach long division. Then you try to teach synthetic. Then you have a day where you try to pull it all together. At a minimum, that was 2 days worth of material. Drop it like it's hot. All right. Okay. Multiply. Add. Multiply. Add. If you really look, you will see that the synthetic does every multiplication and subtraction that the long does. Like for instance, at some moment we did 6 minus 1 equals 5. Do you see that in the other? 6 minus 1 equals 5 was right there. See what I'm saying? Every part of synthetic comes from the long. All right. A lot of kids won't learn this till college, so it's a good thing that you're learning it now. All right. Last but not least, that was the remainder. So do you get, I could have gotten, listen. I could have gotten my factors here from knowing that that's x, that's the constant, and that gives me x plus 1. Note, that's a factor, that's a root. They use opposite numbers from each other. All right, so then this one is x, and there's no number in front of, or no sign in front of the 5, so I put a plus. So there we go, x plus 1, x plus 5. So it's a little more clunky at the end here because I have to make up where the x's go, but it's a lot faster than this. But some of you might just say, you know what, I really like long division better. I'm going to do long division, and I'm okay with that. Your homework for tonight is 5 questions in a row, the first 5. And the last one of those, sorry, number 4, we're going to do long division. The other ones, you may choose. A lot of you are going to choose synthetic. So let's get the worksheet open, and we'll do the first 5 questions. It's only number 4 needs to be done with long division. I want you to prove to me that you can long divide once. All right, yes? I am going to, but it has to be tomorrow because of time. I realize today's one of those days where I have too much to do. Yes? I guarantee you we will grade it, but it just can't be today. Shh. Are you talking in the back again? Because I'm about to break out. I'll open a can. All right.
So
yes?
When it's x plus 5, when is it like x squared? Or, you know how like in the first one we did, we got like 2x squared?
Oh, okay. Because there's no more terms, there was only 3 terms on the bottom, 0, 5, and 1. And the 0 doesn't count because that's just the remainder. We just kind of ignore that. This one's the constant. It doesn't have an x. And then every one after that, it goes up how many x's you give it. That would get an x. If there had been another number, that would have got an x squared. If there would have been another number after that, that would have been x to the 3rd. So if imagine for a second I got done with synthetic and it looked like this. 2, negative 1, 5, 2, 0. The 0 would have told me it worked. And I kind of wall it off. Then I'd say that's the constant, that's the x's, x squareds, x to the 3rds. All right. So now let's look at that worksheet. I'll pause for a second. Okay, just to clarify, because some kids asked, I get your point. Do you see how there are 2 files that both say today's date on it? We are choosing this one that says synthetic. All right. And I'm going to open up the worksheet here. It's under that. Stop with the crinkly noise. Thank you. All right. And here we are. And we're doing the first 5 questions. Do you have a short-term memory? Which one did I say? I know. Yeah, but which one was it that you had to do with long? 4. Number 4. That's this one right here is a long division. I'm going to help you get started here. Are you ready? The first one. There is a flaw in the very first words because it says, is x equals to a factor? Well, I guarantee you x equals 2 can't be a factor. You have never seen a factor written with an x equals 2 in it. Okay? So, hold on just a second here. Tech issues. Just hold on. Shh. That means don't talk right now. Thank you. Okay. It should say, is that a 0? So, we're going to put 2 in our little thing. And then we're going to go 1, negative 16, 28, and then somebody smart. What's different about this one than all the other ones we have ever done? There's no constant. So you put plus 0 as the constant. As I told you before, you don't have to have that, but it will make your life easier if you have zeros to hold places. There was no normal whole number. Yes? Okay, you weren't paying attention. I hate to say it. Because there were too many people talking to you. I'll blame them. All right. Ready? I did address that twice. I even put it on the video. All right. We're dropping this. Drop it like it's hot. Multiply by this. Add. Multiply. Ooh, it looks like it's working. 0, but I don't actually stop. I keep going, and it's okay. It's going to work. 0 times 2 is 0, and 0 plus 0 is 0. Why, you say, did you even want that 0? Because when I wall this off and say, oh, that's just the remainder, 0 is the constant. This one has an x, and this one has a x squared. And if I hadn't had that 0, I might have not put my x in the right spot. Why did I put an x there? Because there was no number at the end of this one. There was no like +7 at the end. All right, final answer, factored form. Who can change this 2 into an actual factor? It's not x plus 2, x minus 2. Very good. And then this part, which is x squared minus 14x. Do you remember yesterday when I was saying a lot of kids get done with all that work and then they have an answer that could have been factored further and they didn't even notice? That one can be factored further. Did you notice? Which part can be factored? Can you factor x minus 2? No. Can you factor x squared minus 14x? Yes. What do they both have in them? An x. So you have to factor that. I'll leave it on there so people can see what I'm doing. Do you get that this one that I'm going to cross off could have been factored to that? You want it factored all the way. If you forget to factor it all the way, the minimum I can mark off is 5% off your test grade. So you went from a 90 to an 85. Okay? So you got to factor it all the way. There's a few things I'm going to plead with you to do at the end of your test. Look back at your factored answers and make sure, is there anything that can be factored further? It's a really common mistake. You know really why that is? Because look at this. Do you get they all have an x in them? They all had an x in them. That's why we have that extra x to factor out at the end. All right. So the solutions. That's easy. X equals 2. X equals 14. And the hardest one, which is just, it's not that hard. It's just people forget that one. X equals, what do you think? 0 for that one. You just put x equals 0. There are 3 answers. Another thing, wait please, another thing that I will commonly mark wrong is kids will have 2 answers. How should they have known there were 3? Look back at the original problem and do you see that it has x to the third? The fundamental theorem of algebra says that you have to have 3 answers then. If your problem has an x to the third in it, there's 3 answers. If your problem has an x squared in it, 2 answers. If your problem has an x, just a plain x or x to the 1, 1 answer. Get what I'm saying? So the hardest ones on the test will have an x to the 5th in them, and there'll be 5 answers. Does this one have any imaginary ones? Did I ever use the letter I? No, that's how you can tell. When would you ever use an I? If you had the square root of a negative involved, then you would have had an I. But I never did a square root of a negative, did I? And therefore, there's no I. Therefore, I'm going to write none here. There. I did the first of your 5 questions. Only problem 4 needs to be done with long, and I will help you set it up. Question first before I move on.
So for the x minus 2 and x minus 14, you do like the x plus square root 2, x minus square root 2, x plus square root 14,
I know what you're talking about, but what you're thinking of is if they had said x squared minus 14. That would have been when you do that thing. We do not need that right now. It's just plain old-fashioned 14 is your answer. All right, let's move down. And this one, you're going to, if you want to start the synthetic, you're going to say 8 goes in the little thing, 2, 4, negative 14, negative 16, and don't forget a 0 to hold the place because there's no number at the end. And wait a minute, is that the identical question? No, it's not. It's slightly different. Okay, sorry. All right, and then I want to help you set up the long just because it's the only one that's different on the whole page. So give me just a second. Why am I hearing George's name? Ah, for Pete's sakes. Can I just like wipe the whole screen somehow? Oh, it'll slide with me. Sweet. All right, this must be a different PDF reader than I normally use. Okay, so on number 4, you're going to go like this. X plus 3 into, nope, I'm wrong, x minus 3. I'm glad I set it up with you. I bet a lot of people would have done that. X minus 3 into x to the fifth minus 3x to the fourth plus 5x to the third minus 15x squared minus 6x plus 18. Holy crap. And aren't you saying at this point, I wish I could do synthetic? Well, on the test, you get to pick. I just want you to know how to do long, because when you move on, there's a type of question that only long division can solve. I don't have time to show you right now, but it's true. On the ACT, synthetic will sometimes work, but when you hit pre-calc and on the ACT, long division is the only one you can always count on. It's kind of like quadratic formula where it'll always work. Some other methods are faster, and like synthetic, but this will always work. So x to the fourth goes here. And already, opposite, opposite, two terms have canceled out. Sweet. Bring down the next two. And then go, okay, what goes into both of those? 5x squared. There, keep going from there. I'm going to pause. Actually, I think that's it. And officially, congratulations, guys. That's the longest video I've done all year. No applause. I know it could be considered child abuse, and I apologize. But we had to get a lot done today. Well, I don't know. You don't want to be called a child, but you know, I'm just saying that's a tough, long lesson. All right. Because that's all I got for today.